Hi everyone. Today I am going to finish this paper. This is the second video of paper 9709, paper 4, variant 2, uh, October November 2019, mechanics paper. So let's start. Okay, first four questions I have already discussed in video 1, so I'll start from question number 5. Two particles A and B moves in the same vertical line. Particle A is projected vertically upwards from the ground with speed 20 meters per second. 1 second later, particle B is dropped from the rest from a height of 40 meters. Find the height above the ground at which the two particles collide. Okay, so let's suppose this is ground and this is a place above height 40 meters. The particle A is being projected upwards and the particle B is dropped from the height. So first of all, you should care about the scenario. Now, for particle A, we'll discuss first the particle A. As the particle is being projected upwards with 20 meters per second initial speed, so u will be 20 meters per second. And g, the gravitational acceleration, this will be minus 10 meters per second square because the particle is moving against the gravity. So we'll take it as negative. Also, let's suppose the time is t, because we don't know the time. We'll find the time later. And one more thing, yes. For example, the height or the distance covered by A is, you can say, height A or distance A, we need to find. Okay, so if you closely see, we can use the second equation of motion. So by second equation of motion, which is S is equal to ut plus half gt square. So now putting the values, S means height of A, HA, u is 20, t is t, plus 1 by 2, g is minus 10, t square. So HA is equal to 20t, this 2 will cancel this 10 with 5, minus 5t square. This is equation number 1. Now, for particle B. Now, for particle B, the particle is actually being dropped from the height 1 second later. Please keep in mind this thing, 1 second later. Okay. Actually, the particle is dropped from rest, so u means initial velocity of this particle will be 0. G will be plus 10 meters per second square, because the part is moving towards the gravity, that's why it will be plus 10. The time will be t minus 1, because it is being dropped after 1 second. So 1 second will be less in the time of particle B. And height of B means distance covered by B we have to find. Okay. Again, from second equation of motion, this will be S is equal to ut plus half gt square. By putting the values, S means height, distance covered by the B, u0 into t minus 1, actually in this case t is t minus 1, plus 1 by 2, g is 10, t minus 1 whole square. So hb is equal to 0, this will 5 times, plus 5 into t minus 1 whole square, or hb is equal to 5 into, we'll open this by the identity, t square plus 1 minus 2t, or hb is equal to 5t square plus 1 minus plus 5 minus 10t. This is equation number 2. Now, as you see that the total height is 40, so the sum of both heights, the height covered by A and the B actually should be 40. So therefore, from 1 and 2, from HA plus HB must be equal to 40. Sorry, 40. This is 40. 40. Okay. Now, by putting the values, HA is 2t minus 5t square, plus HB is 5t square plus 5 minus 10t is equal to 40. Okay, now this t square will be cancelled with this one. Therefore, five. This is 2 minus 10, that is minus 8. So this will be minus 8. 5 minus 8t is equal to 40. Sorry, this is 20 actually. 20t, this is 20. So this is 20, this is 20. So 5, 20 minus 10, that is, this will become 5 plus 10t is equal to 40, and 10t is equal to 40 minus 5, 10t is equal to 35, t is equal to 35 over 10, which is t is equal to 3.5 seconds. So this is the time of the flight of the particles. We need to find the height above the ground at which the two particles collide. So we can put the value of t in this equation number 1 for the height of collision. So from equation 1, HA is equal to 20 into T 3.5 minus 5 into 3.5 square. So this will be 7 70 minus 5 into 3.5 square. So by the help of calculator, when we will solve it, it will be 8.75 meter. So this is the height above the ground when both particles will collide. So that is the answer of part 1. Okay, part 2. Find the difference in the speeds of the two particles at the instant when the collision occurs. Okay, we need to find, first of all, we need to find the velocities right before the collision of these two particles. Okay, for example, for particle A, first of all, we'll discuss the particle A. You remember the particle A was moving upward, so U is 20 meters per second, G was minus 10 meters per second because particle is moving upward. We need to find the final velocity, and we also know that the time of flight of particle A is 3.5 seconds. We already find in the previous part. So from the first equation of motion, because if you see these values carefully, you can easily judge. So V is equal to U plus GT. So VA is equal to 20 plus minus 10 into 3.5. So this will become VA is equal to 20 minus 35. So VA is minus 15 meters per second, or VA is equal to 15 meters per second. Because this negative sign is showing that the body is moving upwards against the gravity. So we just need to keep in mind the magnitude of the velocity. This negative is just telling us the direction of the body, so we need only the magnitude. So velocity of particle A is 15 meters per second just before the collision. For particle B, you remember that particle B is moving downwards from a height, so U was 0 meters per second, G was 10 meters per second square. Particle is moving downwards. Time, actually the time for particle B will be 2.5 seconds, because 1 second later the particle B was dropped. So 1 second less from 3.5, it's 2.5. And we need to find final velocity of particle B again from first equation of motion. We need we know V is equal to U plus GT. So this is VB is equal to 0 plus 10 into 2.5. So VB is equal to 25. This is the velocity of particle B at the time of collision. Therefore, difference in velocities is VB minus VA, which is 25 minus 15 equals 10 meters per second. So this is our answer of second part. Okay, question 6. A block of mass 3 kg is initially at rest on a rough horizontal plane. A force of magnitude 6 Newton is applied to the block at an angle theta above the horizontal. Where cos theta is 24.25, the force is applied for a period of 5 seconds, during which the time the block moves distance of 4.5 meters. Find the magnitude of the frictional force on the block. Okay. First of all, we need to draw the diagram. Always draw the diagram, which will help you a lot during the solution of the question. Let's suppose this is the horizontal ground. This is the block. The weight of the block is actually going downwards. The mass is 3 kg, so the weight will be 30 newtons. The force is acting actually this way, 6 Newton force at an angle theta. So I'll find the theta later and I'll put the value of theta here. Okay, I'll find it now. Cos theta is 24/25. Therefore, theta will be cos inverse 24/25, and by the calculator the theta will be 16.3 degrees. That's why I'll write here 16.3 degrees. Because the force is acting at an angle, so the component of the force responsible for the block's movement will be the horizontal component, which is 6 cos 16.3. Okay, this is the normal reaction, which is always upwards, and here this is the backward resistance, force of friction or resistance, frictional force. So this is the diagram. Okay, what we got already, the block started moving from rest. It means u is equal to 0 meters per second. Also, the block covers the force applied for the time of 5 seconds, so t is equal to 5 seconds, and the block covers the distance, so s is equal to 4.5 meters. This is the data which is already given. We need to find the frictional force. Okay, for this we first need acceleration, so we'll find the acceleration of the block. First, if we closely see, we can use from second equation of motion. S is equal to ut plus half gt square. So this will become 4.5 is equal to 0 into 5 plus 1 by 2 into, sorry, this is A, because the body is moving horizontally, so this is A, not G. So A we need to find, T means 5 square. Now this will become 4.5 is equal to 25, or we can write it as 2 multiplied, because this is 2 multiplied to 25 A. This is, so A will be, this is 9/25, which is 0.3 36 meters per second square. This is our A. Okay, for frictional force we'll use from second law of Newton. F resultant is equal to ma. F resultant, why I use the word F resultant? Because there is a frictional force which is acting opposite to the driving force, so the resultant force will be 6 cos 16.3 minus frictional force is equal to m. M is the mass of the particle 3 and A is 0.36. Okay, so take FC on the other side and 3 multiply this on this side, so it will be 6 cos 16.3 minus 3 into 0.36 is equal to FC. So when we'll find the value with the calculator, will be 5.76 minus 1.08, which is 4.68 newtons. This is the magnitude of frictional force. This is our answer. Okay. For second, show that the coefficient of friction between the block and the plane is 0.165, correct to 3 significant figures. Okay, for this we just need to understand there is a vertical component of this driving force as well, so which is 6 sine 16.3. So don't forget this one as well. So if you see, there are two forces acting vertically upward and there is one force downward, so R plus 6 sine 16.3 is equal to 30 newtons. So R plus 6 sine 16.3 is equal to 30, or I can write R is equal to 30 minus 6 sine 16.3. So this is my R. We know that as we know, frictional force Fc is equal to mu R. Mu is called the coefficient of friction. So put the values. Fc from the previous part, this is 4.68 is equal to mu into R is 30 minus 6 sine 16.3. So take this on the other side, it will be 4.68 over 30 minus 6 sine 16.3 is equal to mu. So by the help of calculator, when you will solve this, this will become 0.165. So it is shown up to 3 significant figures. This is our answer. Part 3. When the block has moved a distance of 4.5 meters, the force of magnitude 6 Newton is removed. The block then decelerates to rest. Find the total time for which the block is in motion. We know that there are two parts of the motion. First is when the force acting on the block, and second when the force is not acting on the block. So we actually know that in the first part of the motion, for first part of the motion, We already know that the time is 5 seconds because the force applied for the 5 seconds. And we also want to find the final speed of the particle at the end of the first part of the motion. So for this we know u is equal to 0 meters per second because the particle started from rest. We need to find distance. We know the particle covered was 4.5 meters and the acceleration of the particle was 0.36 meters per second square. This is from the previous part. So from the third equation of motion, uh, 2as is equal to v square minus u square. Just put the values. 2 into 0.36 into 4.5 is equal to v square minus 0 square. Okay, so finally we'll get v square is equal to 3.24 or v is equal to 1.8 meters per second. This is the final velocity of the particle when the force stopped acting the body. So now the second part of the motion. For second part of motion, when the force stopped acting on the body, we know the final speed of the first part of the motion will become the initial speed of the second part of the motion. So u is equal to 1.8 meters per second because the body will come to rest after some time, so final velocity is 0. We need to find the time of that motion and we need acceleration here as well. So for acceleration, of second part of motion, because the body was moving freely, so frictional force is equal to ma, because the forward and backward force, there was no force acting on the body at that time. So this frictional force is actually called mu r is equal to ma. Just put the values. Mu r was actually 4.95 is equal to 3 into a, or a is equal to 4.95 over 3. A is equal to 1.65 meters per second square negative, because this is deceleration. That's why there must be a negative. So that's why deceleration of the particle in the second part of the journey was minus 1.65 meters per second square. Okay, so we can use the first equation of motion. From first equation of motion, v is equal to u plus at. Okay, 0 is 0, u is 1.8 plus minus 1.65 into time we need to find. So take 1.5 on the other side, it will become minus 1.8 is equal to minus 1.65 into t. Minus will cancel with minus, so t will become 1.65 1.80 over 1.65, which is 1.09 seconds. This is the T2 actually, means the time for the second part of the journey. This is the time for the first part of the journey. So the total time will be total time of motion is equal to T1 plus T2, which is 5 plus 1.09 equals 6.09 seconds. This is the answer of part 3. Okay, question number 7. There are two particles, particle P and particle Q. Particle P got 0.3 kg mass, particle Q got 0.2. They are attached with an extensible string. The string passes over a pulley, smooth pulley, which is attached to the edge of the smooth plane. So this plane is also smooth, so no friction is there. The plane is inclined at angle theta. The horizontal, this is the sine theta equal to 3 over 5, the value of theta. P lies on the plane and Q hangs vertically below the pulley at a height of 0.8 meters from the ground above the floor. The string between P and the pulley is parallel to the line of greatest slope, and the P is released from rest. Q moves vertically down. Find the tension in the string and the magnitude of acceleration of the particle. Okay, so first of all we need to find this theta. What is this theta? As we got sine theta is equal to 3 over 5. So theta is equal to sine inverse 3 over 5, which will give us 36.9 degrees. So theta is 36.9 degrees. Okay. Now, should draw the vector diagram first. The particle's weight will always act downward, which is 3 newtons. This is the horizontal component of the weight and this is the vertical component of the weight. So this angle is also 36.9. So this will be 3 cos 36.9, and this is vertical component. This will be 3 sine 36.9 degrees. This is normal reaction R, and this is the tension in the string in this direction. For this particle, weight of the particle, mass of the particle is 0.2, so weight will be 2 newtons, and the height of the particle from the ground is 0.8. Okay, now for particle P, from second law of Newton, this F resultant is equal to ma. So what is F resultant? This T minus this, because this force is pulling the particle downwards, so T minus this 3 sine. So this will be T minus 3 sine 36.9 is equal to mass of the particle particle P is 0.3 kg, and acceleration is a. We don't know the acceleration. So This will become, this is the, by the help of calculator, will become 1.8 is equal to 0.3a, or take this 0.3a on the left side and 1.5 on the other side. So t minus 0.3a is equal to 1.8. This is equation number 1. Okay. Now, for particle Q, again, F resultant is equal to ma. The particle is moving downwards, so the resultant and the tension in this part of the string is moving upwards. So the resultant force will be 2 minus t, because the particle is moving downwards. So the resultant is 2 minus t is equal to mass of the particle Q is 0.2 and a. Okay, take t on the other side. So this will be 2 is equal to t plus 0.2a, or I can write it as t plus 0.2a is equal to 2. This is equation number 2. So I got two equations. I will solve them simultaneously. So from 1 and 2, t minus 0.3a is equal to 1.8 and t plus 0.2a is equal to 2. So sign change, this will be cancelled. It will become minus 0.5a is equal to minus 0.2. So a will be minus 0.2 over minus 0.5, which will be a is equal to 0.4 meters per second square. This is the value of a. We also need tension. So for this tension, we will put the value of a in any one of the equation, either in 1 or 2. So from 1. This is t minus 0.3a. A, the value of a is 0.4 is equal to 1.8. So t minus, this will become 0.12 is equal to 1.8. So t is equal to 1.8 plus 0.12, which will be t is equal to 1.92 meters. This is the tension in the string. This is our second term. Part second. Q hits the floor and does not bounce. It is given that P does not reach the pulley in the subsequent motion. Find the time from the instant at which P is released for Q to reach the floor. So actually we need to find the time of the particle Q to reach the floor. Okay, for Q, we know that the Q is moving downwards from rest, so that's why U will be 0 meters per second. And the height of Q from the ground means the distance the Q will cover is 0.8 from the picture you can see. And the acceleration of from the previous part, we have found that the acceleration of the particles is 0.4 meters per second square. We need to find the time of reaching to the ground. So for this we will use from second equation of motion, which is uh, S is equal to ut plus 1 by 2 at square. We'll not use g because particle q is not falling freely. Okay, put the values. 0.8 is equal to 0 into t plus 1 by 2 into 0.4 into t square. So this will become 0.8 multiplied 2, this 2 will multiply here, 0.4 t square. So 0.8 multiplied 2 is 1.6 over 0.4 is equal to t square, which will give us t square is equal to 4. Therefore, t will be plus minus 2, but we'll reject the negative value. T cannot be negative, so 2 seconds is the time of the particle reach the ground. This is our answer. Part 3. When Q hits the floor, the string becomes slack. Find the time from the instant at which P is released for the string to become taut again. For this, we need to go to the figure again for a moment. Here, we know that the Q will take 2 seconds to reach the ground. It means the P will also move for 2 seconds upwards. But when the Q hits the floor, the P will not stop there due to inertia. The P will move a bit forward, then back again until the string is tight again. So we need to find the time of that second part of the motion, forward and backward. Because we know the first part of the motion, the time is 2 seconds, plus the time of the forward and backward motion will be the total time of the. So we need to find the time of that second part. For that reason, we need to find the velocity first, velocity of P, final velocity of P. So since the P started from rest, u is 0 meters per second. Distance covered is 0.8 meters because this is the same distance which Q covered towards the ground. The P also covered the same distance. V we need to find, and acceleration time is 2 seconds. 2 seconds. And acceleration is 0.4 meters per second. So these are all things we know from the previous part. So from the first equation of motion, V is equal to u plus at, V is equal to 0 plus 0.4 into 2, V is equal to 0.8 meters per second. This is the final velocity of the particle in the first part of the journey. But for second part of motion, this will become the initial velocity. When the Q hits the ground, this will become the initial speed of the P. So u will be now 0.8 meters per second. V will be 0 because we know the particle will stop after some time. Time we need to find, and we also need acceleration. So for acceleration, we need to go towards the figure again. Look, when the Q hits the ground, there will be no forward force in the upward direction. So there will be only backward force, which is 3 sine 36.9, which will drag the particle, slow down the particle. That's why the particle will move, stop after some time. So this is the frictional force is equal to ma. So for this we will use this relation for acceleration of the particle in the second part of the journey. For acceleration, 3 sine 36.9 is equal to Fc is equal to ma. So 3 Fc is 3 sine 36.9 is equal to mass 0.3 into A. So A will be 3 sine 36.9 over 0.3, which is A is equal to 6 meters per second square negative, because this is deceleration. Body is slowing down. Now, from the first equation, you can find U easily. Find T. V is equal to U plus AT. You know, this is the first equation of motion. Put the values. 0 is equal to U is 0.8 plus A is minus 6 into T. So this will be 0 is equal to 0.8 minus 60. Take 60 on the other side. This is for this. So this will be 60 is equal to 0.8, or T is equal to 0.8 over 6, which is 0.13 second. So this is actually time 2. I must say time 2. This is time 1 for the first part of the journey. This is time 2 for the upward movement after the Q hits the ground, and then the body P will move backward again. So therefore the third part of the time for the backward motion, again the time will be same. So the third time is also T3 0.13 seconds. So total time will be T is equal to T1 plus T2 plus T3, all 3 times. So this is 2 plus 0.13 plus 0.13, which is equal to 2.26 seconds. This is the total time of the particle. So that's it for the paper. This is the end of the paper, video 2. So thanks for watching. See you in the next paper's video. Thank you very much.